Chapter 8, Section 5 is about factoring the quadratic formula, which is an ax squared plus bx plus c. Okay, this quadratic formula, when we are factoring it, we're actually taking it apart, breaking it into two binomials. When you're trying to figure out the numbers that go inside your binomials, you have to find factors that will multiply to equal this c value, but add together to equal this b value. And I'll show you what that means. Alright, so if they give you x squared plus 8x plus 15 and they ask you for the factored form of that, that means they want you to break it down into two binomials. So we need to find out what the two factors are that would multiply to be 15, but add to be 8. Okay, so over here, they start listing factors of 15. 1 times 15 and 3 times 5. And since those are the only two, then we check to see if they add to be 8. 1 plus 15 does not give us 8, so we know that that's not going to work. But 3 plus 5 does give us 8, so we know that that's what we're going to need. Alright, so to do this, we break it down. We know to get x squared, we're going to need an x times another x. So each one of our binomials get an x. Then we're going to use these two factors that we just figured out, a 3 and a 5. And since both my 15 and my 8x are positive, these are also going to be positive. Then you can always double check this final answer with FOIL to make sure that it works. When I do the firsts, I get x squared, outside I get 5x, inside I get 3x, and last I get 15. When I combine these like terms, I get my x squared plus 8x plus 15 that we started with, so we know that this is the right answer. Alright, so we're going to try this down here with the r squared plus 11r plus 24. R squared with no coefficient tells me I just need an r in each one of these binomials. Now, I need a number that's going to multiply to be 24, but add to be 11. Okay, so if I start listing my factors of 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are my only factors of 24. Now I have to see which ones add to equal 11. Not this one, not this one, and not this one. But 3 and 8 do add to be 11, so I'm going to use 3 and 8. And then because these are both positive, these also will be positive. Alright, so today is mostly just practice on factoring for this part 1. So we'll do a few of these together, and then I'll let you try a couple and check your answers with mine. Alright, so the first one, x squared plus 7x plus 12. We need a number, we need an x in each binomial. Then we need a number that multiplies to be 12, but adds to be 7. Okay, so our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, right here, 3 and 4 multiply to be 12 and add to be 7. Okay, and I'm going to need positives of both. Okay, second one, I need an x in each. This needs to multiply to be 16, but add to be 10. So my multiples, or factors of 16, are 1 and 16, 2 and 8, and I already found the one that adds to be 10. So I have a positive 2 and a positive 8. Alright, we'll do one more page together here because this one's a little bit different. Now that I have a minus and a plus, it's going to change my answers just a little bit. I still have an x in each. And I still need something that multiplies to be positive 24, but this time it has to add to be negative 11. Okay, so my factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, in no way will 1 and 24 add to be 11 or negative 11. Same with 2 and 12, same with 4 and 6. 3 and 8 should still work because that will multiply to give us 24. But how am I going to add those together to get negative 11? I would need them both to be negative because when I multiply two negatives together, I get this positive that I need. But when I add two negatives together, I get this negative that I need. So your final answer will be x minus 3 times x minus 8. Okay, similar over here, only this time we're switching variables. Now I need a y in each binomial. And I need a number that multiplies to be 8, adds to be -6. So we're going to list our factors of 8. 1 and 8, 2 and 4. That's all we've got. 1 and 8 do not add to be -6. 2 and 4 will add to be 6. And the way to make them negative is by making them both negative in their binomials. -2 times -4 gives us +8. -2 plus -4 gives us -6. All right, I'm going to have you pause right here, see if you can do these on your own, and then come back to see if your answers match mine. Okay, welcome back. This time I need my numbers to multiply to be a -2, but add to be a +1. And my factors of 2 are just 1 and 2, so that's what I'm going to have to use. If I want them to only equal 1, I'm going to have this be negative and this be positive, so that when I add 2 plus -1, I get this +1. And when I multiply a negative times a positive, I get this -2. Okay, when you did this one, hopefully you had an x in each. And then I needed to multiply to equal -15, add to be +2, which gave me a 5 and a 3. And because I need a +2, the bigger number has to be positive, and the smaller number will be negative. All right, last set before I let you work on your homework for today. I need an n in each, a number that multiplies to be 36. So my factors are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, now I need those to add to be 9 somehow. Okay, now it doesn't look like I can add any of these to be 9, but right here, if one of them is negative, like this one, I'll be able to add to equal 9. Okay, so I have a 12 and I have a 3. Okay, if I multiply to get a negative number, one of these is going to have to be negative, and because I need my adding to be 9, I'm going to have a -3 and a +12. Okay, on this side, I need a c in both binomials. My factors of 21 are 1 and 21, 3 and 7. Okay, 3 and 7 can get me to 4 somehow. These both have to be negatives, so when I have 7 and 3, I need to add to be -4. So if I have a +3 and a -7, I'll end up with -4 by adding, and a +3 times a -7 will give me a -21. All right, so that's all we're going to practice today for factoring. Your full assignment is on page 503, numbers 14 through 19, and then 24 through 40, and 44 through 46, and then, of course, whatever.